Hey Paul, happy Thursday. How are you today?
Great, thanks. How are you?
Good. Where are you calling from?
Columbus, Ohio.
Nice, nice. I'm in Fort Lauderdale today. Tell me more about the company and what you're doing for your customers.
So, Physna is a weird name short for physical DNA, and we analyze essentially physical parts, identify what they are, and who can make them and who sells them. So, we work with like the Department of Defense, finding alternative U.S. suppliers for them, and we do the same thing with automotive companies, aerospace companies, companies in oil and gas, a lot of manufacturing companies as well.
I spent my early career in college life doing 3Ds. Georgia Tech actually did the first high quality water simulation for the Olympics back in '96. And so I was there when they were starting to do that research, and the 3D side really blew up. And then at my last company, we used AI and LiDAR to do digital twins for people's like a body shape in order to do sizing from a social distance. I've dabbled a little bit, but it looks like you're doing quite a bit. What's the main use case that they kind of bring you in for?
So we used to actually go after engineering. People would use us as a way to autofill for 3D, but today people typically use us for a standardization. Like when they're ordering parts, we identify similar parts that might be interchangeable, and then they can save money that way. But the main use case today is actually sourcing. So people will identify what an object is with Physna, and we'll be able to carefully look at the companies that sell that part, and we can also determine manufacturability. So if nobody sells it, we can say, hey, our AI actually understands how that part needs to be manufactured, so we can tell you what companies can manufacture it for you.
How does it work? Are they using like photos to turn it into 3D, or is there a 3D scanning process here?
You can do it either way. So if you have a 3D scan, that works, but most of our customers actually don't start with 3D anymore. We used to require that, but we've worked on a process that actually improves how computer vision works. So instead of relying just on it, even if you have a 2D picture, the user can't tell a difference. They think they're just doing image search, but what's actually happening behind the scenes is we're finding through 3D matching and 3D correlations what that image represents, and then verifying that it's actually the same thing at a deterministic level, and then giving them the results. So you're able to take an image of something like, let's say, a washer or a bolt or something that's really ubiquitous like that, where there might be tiny changes between one and the others. It might almost look identical visually, but we can tell you which one that actually is.
Experience is like.
Yeah, we got started. It's a long story, but basically, my background was actually my educational background was in law, but I had been a serial entrepreneur for a while. And in law, I discovered there was a problem with IP search, like patent search, I should say. Cases where there were like violations of patents and we didn't know where the parts were from. And then I called people in this space and they told me this is actually a problem that extends way past the legal area. It's actually a major issue in manufacturing and engineering and in data science. Realized, hey, there's not a we normalize 3D data, and it's and AI is really useful because we can actually get more insights out of 3D than you can just by uploading 3D models alone. Physna normalizes that into what we would call it the DNA of the part, and that means you can extract orders of magnitude more data from it. So we realized that in the future this would actually be a big deal in AI, and our first customers actually started using it for engineering efficiency. But we found, especially recently with tariffs and Doge and everything, was there's a huge demand for finding alternative suppliers. And so that became the primary use case.
Oh wow, that's amazing. So you must be doing well with that.
Yeah, it's been crazy recently. It's been really busy, but in a
I'm
good
a
way.
watch collector, and there's a lot of memes going on or about how like a lot of the watches that are allegedly Swiss made, it's sort of an accounting thing where 60% of the value is allocated to the Swiss company, but that the majority of the watch is made in China, and also lots of other categories. Is there truth to any of that? Are you guys involved in that?
I personally really into watches too, actually. So that's really neat. But we as a company don't have any watch companies as customers, to my knowledge.
What are you wearing today? Got a blue PRX on today.
I don't have anything on today. More of a newbie in the whole in the watch space. I have a few watches, but I'm just kind of dabbling in it. But yeah, it's an expensive thing to get into, so I've to be careful with it. But yeah, your question is accurate. I mean, what we find is that a lot of people are sourcing, whether it's at the DoD level or it's at, you know, the company level. A lot of companies are sourcing parts from overseas right now in ways that most people don't realize. Like the cars that are manufactured in America, most of those components are made over in China, right? Watches made in Switzerland, most of the components are made in China. They're just kind of assembled at the other in the other country. That being said, there are alternatives. There are companies that make those parts in the United States, and what we've been finding is, not for everything, but in a lot of cases, the parts that they were ordering from China, which now have tariffs applied to them, or they have maybe supply chain issues, or they cost money to import, take time. There are actually companies in America that are already sell them. It's just hard to source because everyone calls the same part, something different, especially when you get down to like the component level. There's not like a uniform naming convention, and that's kind of why we're seeing so much adoption right now. One of the reasons.
Commit to manufacturing the iPhones in India versus China. What does that really look like? Are they still going to be using parts from China, or is this going to be like some model that is 5 years out? Like, do you have any thoughts on like how real is that sort of commitment right now?
On what exactly they're going to be doing, I'm not 100% sure, but I would assume, based on our experience with other supply chains, that it'll take them time to move all the component manufacturing to India. My assumption would be they'd start with assembly in India and the component manufacturing remaining in China for a while, and then eventually switch over. If they really want to commit to 100% made in India, then yeah, eventually the component manufacturing can happen there. I guarantee you all those components can be manufactured in India. Maybe a lot of them already are, but again, sourcing traditionally takes a while.
Yeah, interesting. Talk about some of the other ways you're leveraging AI for growth.
So we use AI in several different ways. Internally in the company, we use it for expediting the a lot of our code, and when we use AI, I strongly encourage everybody, like on a weekly basis, you should be checking what's the latest, at least at a
Yeah.
weekly basis. What's the latest on the market, because AI is moving so fast. If you just think, oh, it's just ChatGPT, you're wrong. And also, you need to be following the news and know which ChatGPT model you should be using, right? So we use ChatGPT in various ways. Our development team uses it prolifically, but they have to be very careful, of course, when we're working with like DoD customers, how they're using it and what tools they use. And we have to follow guidelines there. Outside the company, or I guess in our product, we use AI.
Is DeepSeek is that forbidden in your work because of the security nature of it?
We avoid it because of the security concerns. Yeah, we have to be very careful with things like that. So we don't use DeepSeek. But that being said, we use AI in our tool in Physna. Actually, you're looking at it right now on the screen, like AI predictions, right? So what people are using Physna for that goes beyond sourcing and engineering efficiency, et cetera, is determining, like, how is the part going to perform based on how other parts have performed in the past, or how would this part have to be manufactured, as I mentioned before, or what material should I make this out of? How much should this thing cost me, or how much will it cost to make this part? What else could it be called? And what's really interesting about 3D is that it's extremely rich data. Just traditionally, because people couldn't normalize 3D models, if you were to upload a bunch of models into ChatGPT right now, like 3D models, I mean, and say like analyze all these things, it's only able to look at like what does it look like on the outside, and then what metadata is associated with it. That's it. So it can't see things like, hey, this is the shared geometry, or like if it's a single solid of, let's say, a submarine, what are the components in that submarine, and what other submarines or ships or whatever might actually contain those same components. It can't do that unless it's actually broken down into file hierarchy. And so what Physna does is it overcomes that limitation. And so what we're seeing is a lot of companies being extremely interested in using Physna to actually accelerate AI. And it's people think, well, like 3D models, like how prevalent is that? Well, it doesn't matter if you're in the 3D modeling space. The fact is that the physical world is three-dimensional, right? And when you learn off 3D, it's a lot faster than just learning off images, a lot more precise than just learning off images or even just text. And so it can actually enhance not just three-dimensional reasoning, but also semantic reasoning, language reasoning, and also image, computer vision as well. So we're seeing a lot of adoption in that space, and it's actually helping us to accelerate our growth.
All right. What's the best way to work with you guys? Should they reach out or request a demo?
Sure. Yeah. The best way to reach out to us is you can go to our website. There's a form you can fill out requesting a demo, and that's the best way to contact us if you want to see more about it. You can also reach out to me via LinkedIn, Paul Powers, Physna, Physna, if you can see it on the screen. So that's the best way to contact me directly. But if you want to reach out to the company and like just see more about Physna or learn more about it, then our website at physna.com, that's probably the best way to go.
This is very fascinating. Thanks so much for joining.
Thank you.